All right. So now we're attributing any difference between December sales and the rest of the year to the extra advertising we did in December. I'm not willing to believe that as a causal effect. Okay? So this is where we're going. Two different ways for observational to provide inaccurate results: aggregate time series data, individual cross-sectional data. When the existing data don't give us a valid answer to our question of interest, we should consider generating our own data. And that's what I've been doing in my career. I'm going to skip over this. And just to show off my undergraduate physics background, I claim that our understanding of advertising today resembles our understanding of physics in the 1500s. That's about how advanced we are. And I want to recall my hero Galileo and his development of the experimental method. Question, do heavy objects fall faster than light ones? It seemed obvious from introspection and casual observation. Looking at the data, bowling balls fall faster than feathers. Probably weren't the objects they were actually looking at, but it's a nice modern example. Galileo's key insight was to use the experimental method. Can we hold everything constant except for the weight? Well, the way to do that is to make two balls exactly the same shape and size, but make them out of different materials with different densities, and then say, do they fall at the same rate? Doggone it, it turns out they do. Right? If you don't control for things, then things like air friction can cause things to slow down when they're lighter and have a more spread out shape. But if they're both the same shape and size, they fall at exactly the same rate. Huge advance of the experimental method over introspection and observation, which are the other techniques available at the time. I put up the picture of the Leaning Tower to remind you of the famous story about Galileo, which is unfortunately apocryphal. Galileo never dropped things off the Leaning Tower of Pisa, but he did build these really cool, elaborate ramps that would slope from here all the way down to the end of the platform, so he could slow down the descent of the objects, so he could time them with his primitive watch, which was a container of water with a small leak in it, so he could count the drips. That's how he could measure time at the time. Okay, so end of physics interlude. Marketers often measure the effects of advertising using experiments, but not with actual transaction data. They ask questions like, do you remember seeing this commercial? What brand comes first to mind when you think about batteries? And while they may be useful for comparing two different creatives, two different ad creatives, we're not sure how that translates into actual effects of advertising on sales. And that's the big question I want to go after as an economist. There are some previous experiments that have done this. IRI behavior scan and split cable TV is the most prominent example. They started back in the late 80s. It was a really cool technology. They had sample sizes of about 3,000 households, and it was really hard to get statistically significant effects, even though they're very carefully measuring, this household gets the Kraft macaroni and cheese ad, this household doesn't, and then we can measure what they buy at the grocery store by having their frequent shopper cards. It was a really cool technology, but in a meta-analysis of what they did, out of 300 experiments, 30% of them showed statistical significance at the 20% level. And since 20% of them should be significant at the 20% level if there was no effect, that means that sort of the signal-to-noise ratio was not very high. So we're going to advance over this by having 1.5 million individuals in our experiment as opposed to 3,000. So 1.5 million customers that we match between our database and a nationwide retailer database. This is kind of a high-end department store who doesn't want to be named. 80% of these customers go into the treatment group who see ad campaigns on Yahoo for this retailer. The remaining 20% do not see the ads from this retailer. The ad campaigns are on a run-of-network campaign all over Yahoo. And then after the campaign, we get both online and in-store sales data for each week for each person. Yahoo and the retailers send the data on ad views and on purchases to a third party who then matches the records and then de-identifies them. And then the retailer actually in their sales data used fake dollar numbers. They multiplied all dollar amounts by a factor that they didn't want to tell me, which I did figure out afterwards, but I don't put it in my slides. So by the end of the three campaigns, over 900,000 people had seen ads. You can see the one that I'm mostly going to study here is campaign number 1, which ran for 14 days in the fall, 32 million impressions. Well, I guess I should be using a pointer. 32 million impressions delivered to 814,000 people. So 64% of the treatment group actually saw ads, and of those who saw ads, there were actually 40 ads on average per person. We checked to make sure that the treatment and control groups looked similar. Almost exactly the same percentage female, exactly the same percentage who saw at least one Yahoo page view during the 2 weeks. Of course, the control group is seeing 0%. 0% of them are seeing ads, whereas 64% in the treatment group are seeing ads. Click-through rate on this ad campaign was 0.3%, which translates to a 4.6% clicker rate. 4.6% of the individuals in the treatment group clicked at least one ad during 14 days. I'm going to skip over these. One important thing is that the sales figures vary widely. And the more variance you have in the sales, the more noise you have in your experiment to try to explain. And so having 1.5 million people is really important because it turns out we have mean sales in this week of 94 fake cents and a standard deviation of 14 fake dollars. The min is minus $932 and the max is plus $4,000. And you can see there are 40,000 transactions out of 1.6 million people in a given week. And then these numbers vary a lot from one week to the next as well. So we're going to be looking for a needle in a haystack here, because if there's some small advertising effect, it's only explaining a very small amount of the variance. And there's a huge amount of variance in the data.